Hi Wonder Class and welcome to our maths lesson on Tuesday the 19th of January 2021. So starting off the second day of the week nice and fresh, I want everybody to have a go with the arithmetic. Some of them are worded problems, so have a go. Remember you can try and time yourself and then pause the video. When you press play, I will then reveal the answers to you. Okay, great. So you might have had a chance to now complete some of the questions, and I'm just going to show you the answers on my board over here. So have a look. 9 times 8 equals 56. What integer represents the 10th? The answer to that is 2. What is 248 as a Roman numeral? CCXL. V I. What number is next in the sequence? So it's going up in 20, it's going down each time 25 by 25. So if we take 25 away from 50, the answer will be 25. And 7 times 6 equals 42. And 54 divided by 9 equals 6. 10% of 860 is 86. 4,353 take away 2,101 is 2,243. Put these numbers in descending order. So from biggest to smallest, you would have 9, 6, 5, 3, and 1. And 44 divided by 4 equals 11. So there we have our answers for today's session. Let's have a look what we are learning today. So, can I solve correspondence problems? What do you think that means? What does correspondence problems mean? Quickly clean the whiteboard and we can begin. So here is your 2-minute challenge to begin off our lesson. Using only these digit cards, 5, 3, and 2, and a maximum of 2 multiplication symbols, how many different totals can you make? So I'll give you an example. You might do 5 times 2, 3 times 2, 2 times 3 times 5. See how many different multiplication questions that you can make. Okay, so let's see what we're doing today. So correspondence problems are where a certain amount of objects are connected to another amount. In this problem, we have 2 types of bread connected to 3 types of fillings. The goal is to find out all possibilities. So let's work through this question together to see how we're going to find the answer. So this question would be posed in front of you and it says, a canteen over here, a canteen has 2 types of bread and a choice of 3 sandwich fillings. So a canteen is like our dinner hall. So it's serving 2 types of bread, white bread and brown bread, and it has 3 different fillings, cheese, tuna, and chicken. I wonder if you can think about when we go on school trips. And when we go on school trips, there's often a little sheet of paper that goes home to your parents or carers, and they have to tick what your filling would be in your sandwich. So you get to choose actually cheese, tuna, and chicken. Those are also our 3 fillings. So it says underneath, A, list the different sandwiches that can be made. One has been done for you. So you could have many different combinations of sandwiches. So you could have cheese on white bread. You could have cheese on brown bread. You could have cheese on you could have tuna on white bread, tuna on brown bread. You could have chicken on white bread, chicken on brown. So your choices could vary. And let me just show you what I mean in a much more clearer way. So here's my board again, and I have white and I have brown. Now let's start off with our filling. So we've got cheese, tuna, and chicken. So these are the combinations that I could have with these given bread. So white bread, I could have cheese and white bread. I could have tuna and white bread, or I could have chicken and white bread. And then if I wanted brown bread, I could have brown bread with cheese, tuna, or chicken. So you could write any of these down on your piece of paper. So it says underneath there, complete the multiplication to represent the number of different combinations of bread fillings. So how many breads do we actually have? That's right, we have 2 different types of bread. And how many fillings do we have? That's right, we have 3 different types of fillings. So the multiplication to represent the number of combinations and of bread and filling is 2 breads times by 3 fillings. So 2 times 3 equals 6. So we have 6 different combinations. Then it says on letter number C, how many combinations would there be if there were 4 choices of sandwich filling? So instead of having 3, where we've got cheese, tuna, and chicken, let's think of a 4th one. Maybe egg and cress. So that's a different type of filling. So 4 types of fillings would mean we would do 2 times 4, which equals 8. So the answer would be 8. Okay, let's have a look at this question. It says a pizzeria offers a choice of bases and toppings. So your pizza base could be deep pan or thin, or my favorite is definitely thin. And your toppings are mushroom, chicken, onions, peppers, and sweet corn. That sounds great. So complete the multiplication to work out how many different combinations of pizza there are. So what would we need to do? How many different combinations of pizza? Well, we would just be timesing the amount of different types of pizza base by the amount of toppings. So we actually have got 2 pizza base types, and we've got 1, 2, 3, 4, 5 different types of toppings. So 2 times 5 equals 10. So it says, complete the sentence, there are 10 combinations of pizza. Okay, what I'm going to do now is it's your turn. You're going to pause the video at each slide and try and have a go at completing the questions. Once you've had a go going through all of the questions, which I will also read to you, I will then go over all of the questions and answers for you. So you don't need to complete every single question, but you do need to have a go at reading them and trying them on your own. So let's start off with the first question. So it says, Mo visits the fun fair. He buys a ticket that allows him to choose 1 ride and 1 game at a fair. A, is Mo correct? Mo says there are 8 different possible choices of rides and games. Is he correct, yes or no? And explain your answer. B, list all the different choices Mo can make. Mo can make how many different choices? Remember, pause the video, have a go, and then go to the next question. Aisha has 3 headbands and 5 hair slides. Kim has 2 headbands and 6 hair slides. Who has more choices of combinations for wearing 1 headband and 1 slide? Here are the activity choices available at summer camp. Each child is allowed to choose 3 activities per day. 1 sports over here, 1 arts and crafts, and 1 outward bound. How many activity combinations are there? Have a think about how we've been working that out. B, due to a flooded pitch, football is cancelled. How many combinations are now possible? And Tom and Esther are building a snowman. They have a choice of 5 hats, 4 scarves, and 2 pairs of gloves to dress their snowman. How many different combinations are possible? Okay, now you should have had a chance to have a go at these questions. Pause the video, go back. I'm going to go back to the first one and go through it with you. Okay, so Mo visits the fun fair. He buys a ticket that allows him to choose 1 ride and 1 game at the fair. So it says Mo's saying there are 8 different possible choices of rides and games. Now what Mo's actually done is possibly counted them. So 1, 2, 3, 4, 5, 6, 7, 8. So if he counted them, he thinks that's how many choices he has, but that's not true, because if you count them, you only allow for one Big Dipper, one hooker duck, one dodgems, one hooker duck. It doesn't actually add up. So what we actually need to do is we need to do the amount of rides times by the amount of games. So we've got 3 rides, so we can do 3 times by the amount of games. 1, 2, 3, 4, 5. So 3 times 5 equals 15. So, sorry, 15. So is Mo correct? No, he's not correct. And explain your answer, because you have to times your combinations together. Then it says here, list all the different choices that Mo can make. So I'm not going to list them on here writing with this pen, but you can have a go yourself, so you can see that he can have Big Dipper, hooker duck, Big Dipper, basketball, Big Dipper, coconut shy, Big Dipper, lucky dip, Big Dipper, test your strength. Or he can have dodgems, hooker duck, dodgems, basketball, dodgems, coconut shy, dodgems, lucky dip, dodgems, test your strength. Or finally, he can have carousel, hooker duck, carousel, basketball, carousel, coconut shy, carousel, lucky dip, or carousel, test your strength. So he can still only make 15 different choices. Okay, Aisha has 3 headbands and 5 hair slides, and Kim has 2 headbands and 6 hair slides. Who has more choices of combinations for wearing 1 headband and 1 hair slide? So let's have a look. So we've got Aisha, who has 3 headbands. So I'm going to do 3H just because it reminds me of headband, times 5 hair slides, 5S, that stands for slides. And then I'm going to do 2 headbands for Kim times by 6S as in for slides equals. So really what I'm doing is 3 times 5, which equals 15. That is for Aisha. And 2 times 6, which equals 12. And that is for Kim. So who has more choices? The answer to the person who has more choices is Aisha. So you're going to put there, Aisha has more choices. Okay, on this question, it's asking us to find out how many combination activities are there. So in sports, we're going to be times in sports, times by arts and crafts, times by outward bound. So how many do we have in sports? So in sports, we've got 3, football, tennis, and golf. So we're going to do 3 times by painting, pottery, mosaics, and origami. That's 4. So 3 times 4. And how many do we have in outward bound? Wall climbing, kayaking, abseiling. We have 3. So essentially, what you're actually doing is 3 times 4 times 3, which equals 36. So the amount of combinations you have is 36. Now the question B says, due to a flooded pitch, football is cancelled. Now how many combinations are possible? So if we go to where football is, so football is in the sports column, and for the sports column we times by 3, nothing else has changed in arts and crafts or outward bound. So we take away football, that will leave us with only 2 combinations over here. So if I cross football out, there's only 2 combinations. So I'm going to be doing 2 times by 4 times by 3 instead. And I know that 2 times 4 is 8, and 8 times 3 equals 24. So my answer now would be there are 24 combinations. Tom and Esther are building a snowman. They have a choice of 5 hats, 4 scarves, and 2 pairs of gloves to dress their snowman. So how many different combinations are possible? Maybe by now you might have caught on to what we do. We're going to do 5 hats times by 4 scarves times by 2 pairs of gloves. So 5 times 4 equals 20. So we could do 5 times 4 equals 20. And 20 times 2 equals 40. Fantastic. So there are 40 combinations. Okay, that is all from me today, everybody. Well done for having a go with these questions. I've you might have noticed as the first one was beginning, it was a little bit confusing, and as it went on, you should be able to have understood a little bit more on how we're actually answering these questions. And it's just about looking at the numbers, breaking them down, and really seeing what the question is asking us, which is why reading is so important, because it comes in to all of your subjects and everything that you do. That's all from me today. I will see you all in tomorrow's lesson. Bye, everybody.